but to do it, we're going to start with some general rules or formulas regarding them. And in order to define the formula, I need to redefine this concept or word called diagonal. We've already talked about this when we looked at convex and concave polygons, which I'll remind you when we're done with this. But the definition of a diagonal is a segment that joins two non-consecutive vertices. And I'll illustrate non-consecutive vertices here in a moment. So if you pick any vertex anywhere along this polygon, so let's say we pick this vertex right here. Okay, every diagonal you can draw from this vertex is just a segment connecting that vertex to any vertex other than the two right adjacent or right consecutive to it, which would be this one and this one. Okay, so here would be a diagonal, and here would be a diagonal. Okay, now, from each vertex, you can draw in all the diagonals of a polygon. Okay, and so we could do the same thing from each point, and in doing that, you would get all the possible diagonals. And you do the same thing from this point. So all of these illustrate the possible diagonals that you can find. Now, if any of these diagonals fall outside the figure itself, then it would be considered a concave polygon. We talked about that in an earlier chapter. For these ones and all of the polygons that we're going to be calculating sum of angles for, they will be convex polygons, meaning all parts of all of their diagonals fall in the figure itself. They never go outside the boundary of the figure. All right. So we'll use this here in our next definition to find what the sum of the measures of these polygons are. Okay, so if you want to know what is the total sum of all the angles in any polygon, the way that you can find that, and we're going to derive it first, is if we took all the diagonals we can draw from any one vertex. So here I'm going to choose this vertex down below, draw in all the diagonals from that vertex. And what I notice is by drawing those diagonals, I create triangles. So here I create 3 triangles from this polygon with 5 sides. And each of these triangles has a total sum of angles of 180. So this is 180, this is 180, and this is 180. And each of those triangles' angles actually form all the interior angles of the whole polygon itself. So here when I take triangle 1, triangle 2, and triangle 3, notice the angles that are combined for those 3 form all of the angles of the polygon itself. And so that gives you or leads you to the formula for calculating what the sum of the interior angles of any polygon is. And the way that we do it is we're going to take 180 degrees times the number of triangles that are formed in this polygon. And here you see that we have a 5-sided figure. So n is just represents the number of sides. So here we have a 5-sided figure and the number of triangles is 3. If we took a 6-sided figure and we drew in our diagonals, so if n is 6, we see that there's 4. And what you're going to see is the n value, the number of sides, and the number of triangles are always going to be related by n minus 2. Okay? And so that's the formula that we're going to use. N minus 2 times 180 is the equation or formula for finding the sum of the interior angles of a polygon. Okay, so I want you to use that and answer these 2 questions up here, please. And if you ever forget the formula, just try to recreate it. Draw a quadrilateral or a pentagon and draw in all the diagonals to see how many triangles it takes, and then just multiply that number by 180. And once you get to larger number of sides, like doing a drawing isn't quite the same, so you want to try to find the pattern of it if you don't memorize the relationship. With a lot of what we do on MyOpenMath, the most efficient way to approach this problem is to enter your answer as a calculation. It also shows you understand what the formula is. So if my n value is 5, I can take n minus 2 times 180. 5 minus 2 times 180, just plug that directly in. If you do the calculation here, again, 5 minus 2 times 180, you would get your answer of 540. So you can enter a calculated value, or you can enter the calculation. So once again, to me, the easiest thing to do is just type in your calculation. So if n, the number of sides, is 21, 21 minus 2 times 180 is the easiest way to probably do this. But you could also, on the calculator, because of the being able to work with the slider, if you have multiple questions that are asking the same thing, what we can do is we could take just the general formula for this. Oops. If we took n minus 2 times 180, created a slider here, and we just replaced that number of sides with what the problem designates. So 5 sides gives us 540. The next question, 21 sides. We just changed this to 21, and it corresponds to our next answer, which is 3,420. Okay, so when you're answering these questions, if you want to create a slider and answer multiple questions at once, you can. All right. The next question is sort of going in the reverse direction. Okay, so if you're being asked to find what number of sides would a polygon have if the total sum of interior angles is 720, I want you to see if you can find that with the idea that in this case, n must be a whole number. Right? N is the number of sides. You can't have a fractional side. And so if you're calculating for n in these polygons, n has to be a whole number, otherwise it's not possible. And so see if you can answer these two questions here before I go through them, based just on the formula that we have, n minus 2 times 180, and the concept that n has to be a whole number if you're solving for it as your unknown. So a lot of you, when you're working through problems, I do notice that you enter your calculations or your or equations directly in the answer field, and then you start manipulating them in there, which is fine. So if you're doing that, this would be the original setup, right? The formula n minus 2 times 180 is equal to, and it told you what that measure was, so we set it equal to 720. And now if we're going to solve this, we divide by 180. You take 720, divide by 180, you get 4. And now you add 2. Don't forget that step. That's probably going to be the most common mistake, is that students will enter their answer for this, and it'll be 2 fewer than it's supposed to. Make sure you add that 2 back, and so you get n to be 6. Okay, now, when we look at what happens here in this next example, okay, so if we take n minus 2 times 180 equals, I'm going to write it over here, 16,520. So if I take 16,520 and I divide by 180, notice I get this decimal. Okay, so if I then took this and tried to add 2 back to it, I don't have a number that is an integer or whole number. Okay, which means that it cannot be. There cannot be a polygon whose sum of interior angles is 16,520. Okay, and so if that's the case, you would enter DNE, not possible, and for that question. All right, so try this last question here. Again, it's relatively intuitive based on what you're looking at. And if you know what each of these angles is and you know the number of sides, can you find what x has to be in this diagram? Again, you know you need to find what the total sum of these angles is. You can then subtract the given angles from that, and whatever's left is your value x. So you can either use the formula, or if you just quickly sketch, how many triangles are you creating here? So 3 triangles, or I'm going to enter this in my answer field. Remember, you can do that too. So 3 triangles times 180. Now, if you wanted to enter your formula directly, you would take the number of sides, 5 minus 2 times 180. And then you just start subtracting the given angles. So subtract 86, subtract 135, subtract 149, and subtract 58. And when you do that, you'll be left with your final answer here. So if I took 5 minus 2 times 180, and then subtract 86, 135, 149, and 58, I get my answer of 112, and that's the remaining angle measure. But you can enter a calculation, or you can do the calculation and enter your final answer. All right, so this is just the basic, this is the formula that we're going to kind of base what we do our work on here for the next couple slides. All right, before we move on to the manipulation of this formula, I just need to redefine a couple things. I believe we've talked about this before, but I want to make sure since it's relevant to what we're going to be doing. Okay, these terms, equilateral polygon means same, lateral refers to side measures, and so this is a polygon where all sides are congruent. The tick marks demonstrate that. Equiangular means all angles are equal in this, or congruent in this polygon. Again, the tick marks show that. And finally, when you combine those, you have this term called regular. And this is the one I'm not quite sure if we've gone through this before or not. But regular polygons mean that it is both equilateral and equiangular. Equiangular meaning all congruent angles, equilateral meaning all congruent sides. Okay, and the tick marks there show as well. Now the two main sort of regular polygons that you've already worked with a number of times is equilateral triangles, are both equiangular and equilateral, and the regular quadrilateral, both equiangular and equilateral, is a square. So those would be the measures, but we're going to expand this out and start doing other types of regular polygons as well. Okay, which brings us to taking any regular polygon and finding what each interior angle would be. And if we know what the total sum of the angles is, and we know because it's regular, it's equiangular, that each angle has to be the same, you can find what each interior angle is for a regular polygon by taking that sum, n minus 2 times 180, and divide by the number of sides. So this is going to be your formula for calculating what each of the angles is in a regular polygon. So once again, start with the one where it's just applying the formula correctly. So see if you can calculate the measure of each interior angle for regular polygons with 20 and 84 sides. So once again, if you're familiar with the formula, you just can plug that in, right? N minus 2 times 180 divide by n. Make sure if you are taking n minus 2 on your own, that you're not dividing by that same n minus 2 value. So make sure you keep it the n. So here we would get 20 minus 2 times 180 all over 20. That gives us our angle measure of 162. So that would be your first measure. If we did the same thing that we did previously, which is if we create a formula for this, if we have to answer a couple questions using the same relationship, what we can do is take the formula n minus 2 times 180 divide by n, and we can create a slider where we then just change this to the number we need. So we want that to be 20, and we see, again, it's 162. If we want to change that to the second problem, 84, I just change the values, and I get 175.71. It says to at least 2 decimal places, so this should be good. If I had entered my calculation, it would be 84 minus 2 times 180 over 84. So those would be my answers. Can I have a decimal for my answer here? Is it possible for an angle to be a partial measure? Yeah. The one that's not is n. You can't have a partial n because n represents like number of sides. Okay? And number of sides, they're either there or they're not. There's no portion of them. Okay? With the exception of, and that's just the wording of, when we look at this next relationship here, if you see approximately in the problem, okay, it means that it's giving you a rounded answer. So when you're calculating the n value on these, you are going to just round it up. Okay? And it will always be really close to that integer value or that whole number. Okay? So if your answer is 15, you're going to see either 15.001 or 14.998, something like that. It's going to be that close, and for those calculations, because the numbers that they use are ones that come from the integers themselves. All right, so I want you, so this one is a slightly more complex calculation. I want you to try the first one, just this first one here on your own. Okay, I'm going to show you the second. I'm going to show you a different method for the second problem. So just try the first problem, see if you can apply this formula along with the measure they give you, and see if you can calculate what n is. And again, it might be a decimal, and if it is, round it, because it asks you or tells you that the 175.044 is an approximate measure. So as you go through this calculation, again, be aware that I'm going to show you a much easier way to do this in just a moment. But in order to show you the easier way, we need to get through the next couple sets of slides. So we'll come back to this problem after that, and you'll have a more efficient strategy for answering these. All right. So all we really have right now is we have this formula, n minus 2 times 180 over n. And we know that that's equivalent to this value, 176.044. Okay. So this is what we know. And if we're solving this now for n, we first cross multiply, or multiply both sides by n, get rid of our fraction. We then distribute the 180. That gives us 180n minus 360 equals the 176.044n. And so here we can start to calculate what we have. So we're going to subtract 180n from both sides. That gives us negative 360 is equal to, and if we take that measure, 176.044 minus 180, we get negative 3.956 n. Divide both sides by this number. And so here we get negative 360 divide by negative 3.956. And you can see here we're rounding our answer, right, because it says approximately. We get 91 for n. And so that would be our measure. All right. As I mentioned before, I'm going to come back to this second problem, and I'm going to show you a different way to go about it. And that different way pretty much jumps right to this step. Okay, so it skips the whole first two lines, jumps right to that last line. So we'll talk about it here in just a moment. And so, but first, let's refer to the other type of angle pairings that we see in polygons, and that is the exterior angles. And so notice here that angles 1, 2, 3, 4, and 5 are exterior angles. If I say angles A, B, C, D, and E are these interior angles. And so if you look at all of these angles here, each pair of interior and exterior angle are a linear pair, right? So in this figure right here, how many linear pair do I have? I have 5 linear pair, right? 5 groups of 180. Well, if I go in and I use the process that we just talked about to create triangles in here and draw my diagonal, how many triangles do I have? 3 triangles represent the interior of these angles, the interior angles. And so if I have 5 180s, 5 linear pair, minus 3 triangles, which are also 180s, how many 180s am I left with? 2 180s, which is 360. It doesn't matter how many sides your figure has. we can even go back to triangles. If we look at a triangle, which is also a polygon, you have 3 linear pair, so 3 180s. And how many total triangles are there in that triangle? Just the one group of 180. That leaves 2 180s. No matter what you do, it's always going to come back to 2 180s. It's where that n minus 2 comes from. Okay? And so when you look at the sum of the angles in any polygon, is always going to be 360 degrees. Okay, which means you couldn't get any easier than this question. See if you can answer those two really quickly. Some of the exterior angles, the second you see that, you know your answer, 360. Doesn't even matter what number of sides are. Some of the exterior angles, you know it's 360. Okay. This next one also should be relatively intuitive, similar to what we did on the a couple slides ago. See if you can quickly calculate that. So here you're calculating A, B, C, D, E, and F are exterior angles, and so you take the sum of them, which is always 360, and just start removing what you have. So A is 92, B is 53, C is 58, D is 51, and E is 43. If we remove all of these, we're going to be left with what F has to equal. And so the total calculated value, again, entering it in this form would give you your calculation if you did it by hand, and then substituted that in, you would get a total of 63 for your answer. Okay, but don't be afraid to use the most efficient way, which is just to enter the calculation. All right, so the final slide that we're going to look at, and then we'll go back and revisit the one from earlier. But the final slide is the same idea of what if we have a regular polygon, and we know that the sum of the exterior angles is 360. How can we find what each exterior angle is? And it's the same concept. Here we know that each of these exterior angles is exactly the same. You know that the total sum of them is 360, and so you get your calculation that each exterior angle is 360 divided by n. Okay, so go ahead and solve these two here quickly. The easiest thing to do is you want each exterior angle, so the sum of them 360 divided by the number of them 12. The sum of them 360 divided by the number of them 32. And so that would give you your answer. You could do the same thing that I talked about earlier, create a slider, 360 over n, and just plug in the number that they give you for n. So when n is 12, we see that each of these exterior angles is going to be 30 degrees. And if n was 32, we just change that, and each of the angles would be 11.25. Okay, so find a way that makes sense or that's easiest for you to do that. All right, so that brings us to this final question here, which is, if you know that each exterior angle is equal to 360 over n, what if you were given the exterior angle and you're asked to solve for n? Well, if that was the case, we would need to multiply both sides by n, and then divide both sides by each exterior angle. And notice this gives us that calculation. N is equal to 360 divided by each exterior angle. So it's the same one, right? It's whether we're finding what each angle is or what n is, we're taking 360 divided by the other given calculation. So if you know that each exterior angle is approximately, here's that word approximately, that means that you're going to get, that you are going to round your n value, although you normally, for n's, need to be whole numbers. If it does say approximately, look for it to be a number that's close to the whole number and round it. But see if you can answer both these questions here. It's a nice, easy calculation, right? It's 360 over the angle, so we could enter it as 360 over that 5.455. Here we can enter 360 over the given exterior angle, 25.714. We can also set the same relationship. I'm going to call it, well, I'm not going to call it x, but I'm going to call it a here, because a is the angle, the given angle measure. And so if we change this angle to 5.455, what we see is the given angle measure is approximately 66 degrees. Now, here's the one thing to be careful of. If you enter your answer as a calculation right here, it may not read it as being accurate. And the reason for that is, can you have a side with 65.99 or can you have a polygon with 65.99 sides? No, you have to physically round that up. Okay, so make sure that you are entering your answer. So if you enter the calculation, make sure that before you actually, exit and hit submit, round it to 66. Round it up to that number. Okay, so if your A value or your given angle was the second problem, 25.714, your angle would be 14. When you round it, make sure that you round that angle. Okay. This needs to be done. Round your answer to the nearest whole number. All right, so looking at these, which calculation was easier, this one or this one? The exterior angles, right, by quite a bit. So what you can do to solve a question like this, if we come back to this last problem here. If you're told what each interior angle is, and so if you're told what each interior angle is, can you find the exterior angle? What's the exterior angle that corresponds to 176.129? How would you find that? Subtract it from? They're a linear pair, right? They look like this. Here's your interior angle. That means that this exterior angle is just its linear pair. So what we can do with this is we can take 360 and divide by the exterior angle, which is 180 minus this given angle. Okay, and so that's the calculation. You could enter it. Now remember, once again, we need to round our answer here. Okay, and so if you enter your answer as this calculation, 360 divided by the quantity 180 minus 176.129, we get 92.99, which means you're going to enter your answer as 93. So